Engineering blunders at sea, lessons from historic ship design failures. The Titanic tragedy is emblematic of a catastrophic oversight in emergency preparedness. The infamous ship sailed with insufficient lifeboats for its passengers, a stark underestimation of safety needs that led to a grave loss of life. In 2012, the Costa Concordia disaster highlighted the dangers of technological failures. A flawed navigation system steered the ship too close to shore, resulting in a modern tragedy through human error and technological inadequacy. The Vasa ship, a 17th century marvel, met its demise immediately after setting sail, primarily due to its imbalanced design. This engineering misstep underscored the critical importance of balance and stability in naval architecture. The Herald of Free Enterprise ferry disaster was a stark reminder of the consequences of ignoring operational procedures. Leaving the bow doors open as the ship set off led directly to a fatal capsizing, emphasizing the importance of strict adherence to safety protocols. The Eastland disaster was a tragic result of excessive capacity modifications, which compromised the ship's stability. This deadly instability serves as a cautionary tale about the risks of altering a vessel's design without thorough safety considerations. The Kursk submarine sinking was a grim exemplar of inadequate safety protocols within nuclear propulsion systems. Despite its advanced design, overlooked flaws in maintenance and emergency response led to a preventable tragedy. Flawed navigation and overconfidence in the Costa Concordia's technological prowess culminated in a disaster at sea. The ship's grounding off the Italian coast underscored the fatal consequences of relying too heavily on technology. The Vasa's maiden voyage ended in disaster due to an imbalanced design that was not rigorously tested. This 17th century Swedish warship sank within minutes of setting sail, marking a historical engineering failure. A simple procedural oversight on the Herald of Free Enterprise led to one of the most devastating maritime disasters. Leaving the bow doors open compromised the ferry's stability, resulting in a tragic loss of lives. The Eastland disaster highlighted the dangers of modifying vessel capacity without considering stability implications. This led to a catastrophic capsizing in the Chicago River, emphasizing the importance of balanced design and safety regulations. The RMS Lusitania's design, optimized for speed and luxury, tragically also made it an ideal target for German U-boats during WWI. Its swift sinking after a torpedo strike exposed critical vulnerabilities in its structure. The Hindenburg disaster showcased the grave dangers of using hydrogen for airship buoyancy. The catastrophic explosion upon landing in New Jersey highlighted the volatile nature of hydrogen, leading to a re-evaluation of airship safety. When the Prestige oil tanker split in two, it wasn't just a structural failure, it became an environmental nightmare. The spill devastated marine life and coastlines, underscoring the dire consequences of neglecting maritime engineering integrity. The Columbia Space Shuttle tragedy was a somber reminder of the importance of heeding engineering advice. Damage to its thermal protection system, initially dismissed, led to its disintegration upon re-entry, a loss that reverberated worldwide. Deepwater Horizon's explosion was a chain reaction of engineering oversights and safety failures. This disaster not only claimed lives, but also unleashed an unprecedented oil spill, highlighting the critical need for rigorous safety protocols in drilling operations. The Quebec Bridge collapse is a stark reminder of the perils in underestimating structural engineering and material strength. This misjudgment led to a tragic failure, highlighting the importance of precision in engineering assessments. Overcrowding and neglected boiler maintenance spelled disaster for the SS Sultana. The explosion that followed serves as a grim lesson in the critical need for stringent safety measures and regular maintenance checks. The Chernobyl disaster stands as a chilling testament to the catastrophic outcomes of flawed reactor design and operational errors. It underscores the dire consequences of overlooking safety in pursuit of other objectives. In the case of the Fukushima Daiichi nuclear disaster, a devastating mix of natural forces and engineering shortcomings resulted in one of the worst nuclear calamities, emphasizing the need for robust, disaster-proof design. The collapse of the I-35W Mississippi River Bridge brings to light the fatal consequences of failing to adequately account for structural weight and weaknesses, underscoring the vital role of continuous inspection and maintenance.